Good day to all of you. Today we shall discuss question number 9a from model question paper set 1 of the subject digital design and computer organization with subject code BCS 302. The question is as follows. With the diagram explain the single bus organization of the data path inside a processor. It carries 10 marks. So to answer this question we need to know this diagram. So this is the figure 7.1 given in the textbook Computer Organization 5th edition by author Karl Hamacher. Our sincere acknowledgement and thanks to author Karl Hamacher. The whole content of the discussion is taken from this textbook. Before getting into the core discussion, let us know the terms or different parts in this diagram. So this is internal processor bus that connects the different parts of the processor inside. This is memory bus or external bus that connects memory with the processor. This is program counter which stores the address of next word or next instruction. MAR means memory address register. It stores the address of memory location with which the processor wants to communicate and do either read or write operation. This is memory data register MDR. It stores the data sent to memory or taken from memory, that is in write operation or read operation by the processor. This is instruction register. Whenever a word is fetched from memory, if it is instruction, that will be saved in instruction register. This is instruction decoder and control logic. This instruction decoder will decode the instruction taken from instruction register and it will assess what operation to be done and where are the operands. Accordingly, control logic generates control signals to activate ALU and different parts of the processor as to do the specified operation from the instruction. Next, R0, R1 till R of n minus 1. These are the general purpose registers. So the number of general purpose registers vary from processor to processor. If there are 16 general purpose register in a processor, their numbering is from R0 to R15. Totally 16 general purpose registers. That is what is R of n minus 1. So 16 minus 1, it is 15. The last register number is R15. So R0 to R15 make 16 general purpose registers in that processor. So this number varies from processor to processor. So they are used to store temporarily some data during the execution by the processor. This is arithmetic logic unit. So two operands are given to that. Then control logic, what signal sends here, depending on that ALU performs arithmetical or logical operations on these two operands. And what result is generated, that will be saved in Z register and over internal bus that will be sent to general purpose registers for storage. So this PC always stores next instruction or next word address. So if processor is executing present instruction which is stored at memory location 1000, then the next word address will be 1004. So while generating next word or next instruction address, this constant 4 is used. Select line of the mux will choose this constant 4, send it as output of the mux and it is made as one of the operand to ALU. Here 1000 is sent. 1000 plus 4 will be done when control logic sends add control signal here. So the resulting 1004 through Z and over internal bus, it will be saved in program counter. This is how PC is made to point to next word or next instruction address. Okay, these are some of the terms involved in this diagram. So with this discussion we shall go to the content of the discussion. bus organization of the data path inside the processor. Internal bus connects ALU and all registers. So the all registers in the sense here general purpose registers or other registers like program counter, memory address register, MDR memory data register, instruction register, and apart from general purpose registers, the processor may have some of the special registers also. So the interconnection is done by internal bus. External bus connects processor, memory and IO devices. MDR and MAR connect external data and address lines with internal bus. This MAR, MDR connect external bus to the internal bus. So data may be loaded into MDR either from external memory bus or internal processor bus. That is, the data may be loaded into MDR either from internal bus or from external bus. Hence, MDR has two inputs. The data stored in MDR may be placed on either bus. Means the data in MDR that may be sent to either internal bus or to external bus. The input of MAR connected to internal bus and its output is connected to external bus. So MAR input means here the incoming arrow line is there. So MAR input is connected to internal bus, its output is connected to external bus. The control lines of memory bus are connected to instruction decoder and control logic block. See, whenever a word is brought, if it is instruction, it will be saved in instruction register. The control lines of the memory bus will be connected to instruction decoder and control logic block. This unit is responsible for issuing the signals that control the operation of all the units inside the processor and for interacting with memory bus. So this control logic circuit, this instruction decoder and control logic circuit, this block is responsible for generating control signals that control and coordinate the activities of all different parts of the processor and the processor interacting with the memory. R0 through R of n-1 are the processor registers whose number may vary from processor to processor. That is, these general purpose registers. Their number may vary from processor to processor. So some are general purpose, some are special like index register, stack pointer or accumulator. Means apart from general purpose register, a processor may have some special registers like index register, stack pointer or accumulator. Why those registers are called as special registers? Because unlike general purpose registers which are used for some temporary storage during execution, those are used for some special functions. They are used for some special functions. Hence they are called as special registers. The mux selects either the output of register Y or constant value 4 to be provided as input A of the ALU. The constant 4 is used to increment the contents of PC. Select 4 or select Y are the two possible control units to mux for selecting constant 4 or register Y. So here for mux, select is the control signal that is sent by control logic. So if it is 0, this Y will be selected. If it is 1, constant 4 will be selected. That is, by control signal on the select line, any one will be selected. This constant 4 is selected when generating the next word or next memory location address. Suppose PC is pointing to 1000 memory location. So that instruction will be loaded and processor will execute that. While processor is executing that, PC has to be incremented by 4, that is one word. Means PC should be made to point to next instruction. So for that, the select line will select constant 4, that will come here. This PC content 1000 is taken, 1000 and 4 are added. So by ALU, 1004 generated, that is sent to Z. Over internal bus it is saved in PC, that program counter. This way program counter is made to point to next word or next memory location. In that case constant 4 is added. Otherwise select line is made to choose Y in. The instruction decoder and control logic unit is responsible for implementing the action specified by the instruction loaded in the instruction register. So which control signals must be generated by the instruction decoder and control logic depends on what instruction is stored in instruction register. So that instruction will be decoded by instruction decoder and gets to know what operations must be done and where are the operands. So to execute that operation on those operands, then control logic will generate corresponding control signals and activate the different parts of the processor along with ALU to do that operation. Okay. The decoder generates the control signals needed to select the registers involved and direct the transfer of data. Means whatever operation that is told by the instruction stored in instruction register. So instruction decoder, after decoding it gets to know that then what control signals are needed to select the registers involved and direct the transfer of data. The decoder will generate corresponding control signal. The registers, the ALU and the interconnecting bus are collectively referred to as data path. Then what is data path? So whatever registers are here and ALU and the interconnecting bus all together, this is called as data path. Okay. So that completes the discussion. So what was the question? With the diagram explain the single bus organization of the data path inside a processor. So data path here in the sense ALU, the different registers and interconnecting bus all together forms the data path, and corresponding discussion is completed. I hope you understood. Thank you.